I am not ready. Hold on. Thank you, lady. Let me see. So I got a question about, I got two questions now. 9585. Okay, so what is it about this problem? Let me see. So here's the problem, right? So the mean work week for engineers is believed to be about 60 hours. All right, that's a little bit funky. I agree with you. A newly hired engineer hopes that it's shorter. She has 10 engineering friends for the length, blah, blah, blah. So what's the claim that's being, I don't know. Do you have a more specific question? Here we go. Okay. All right. No need to yell at me in the chat. I will do that next. I'm just doing these in the order that I got them in. I like that. Okay. Okay. So, okay. I'm not going to get more specific stuff. So you just start off the same way you always do. What's the claim? In number 85, what's the claim that's being made?
Mu is equal to 60 hours.
No. Thanks for playing, though. Quick on the buzzer, as always. Anybody else?
Greater or equal to 60 hours?
No. So based on the results that follow, should she count on the mean work week to be shorter than 60 hours? Right, so she wants to test that claim that it's shorter than 60 hours. So mu less than 60. I'm not going to go through each step, but I don't know where the issue comes up. Are you going to use z-scores or t-scores? Why z-score? Let me ask that a different way. Why is it not z-scores? Yeah, why is it a t-score? What do you have to know to be able to use z-scores? What must you know to be able to use z-scores?
Population standard deviation.
Population standard deviation. I don't know that here, right? Not that I see. Did I miss it? No. I'm going to have to get my standard deviation from one of our stats of this data, right? You guys with me? So I'm going to have to use a t-score. Another thing is, she only talked to 10 people. N is 10. Is that okay? But a lot of people miss this. Note, if you are using a student's t distribution, you may assume that the underlying population is normally distributed, blah, blah, blah. So that's fine. We don't need N to save us for this problem. You guys, everybody still with me? How about this? What the hell is alpha? What's alpha in this problem? What's alpha? Yeah, you assume it to be 0.05. If they don't tell you what alpha is, you assume it to be 0.05. That's the most commonly used alpha. So that's what you assume if they don't say. So everybody, is that better? I don't know. Is that helping at all? Because then you have to put that data into your calculator. You have to get the X bar and the S, and then you do your T star just like normal, right? One thing to be careful about. Oh, conclusions. Okay. So in this problem, let me see. Let me change my screen here so I can write on this. Oh, crap. Where am I at? There it is. Jeez. I got too many freaking windows open on this thing. There we go. All right. Let's see. So I already know ahead of time what the conclusion could possibly be. I know that the minute I start. So remind me, the claim was shorter than 60 hours. Is that going to be HO or H1?
H1.
Definitely, because it does not have an equal sign in it. So my claim is H1 or HA, if you want to use what the book does, right? Let me stop for a minute. Is that cool with everybody? Step 3, you do the rejection region, right? And it's going to be down here somewhere, and you can look up the t-score, blah, blah, blah. But if I get in there, I reject H0. I support H1. And if I don't get in there, I fail to do those two things. Is everybody with me? If I get in here, I do these. If I don't get in here, I fail to do these. So what language will I use for the conclusion? Well, since the claim is H1, I'm going to use this language. So depending on where my sample falls, in here, out there, I'm going to either support the claim that blah, 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 or I'm going to fail to support the claim that blah, blah, blah. I want somebody to write blah, blah, blah. Baby blah, 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 blah. That's the unknown song sung by whatever boy band that was. I don't know. Can you repeat again what happens if you get in the rejection region? The reason we called it that is because that's when I can reject the null, which means that's when I support the high. If I don't get out there, I cannot reject the null. I fail to do these two things. So your conclusion on this problem will either be, we have found sufficient evidence to support the claim that the mean is less than 60 hours, or it will be, we have not found sufficient evidence to support the claim that the mean is less than 60 hours. So if you don't get into the shaded, you fail. Yes. Yes. And again, I really, 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 really want this to make sense. The HO is the one that has an equal sign. So it's always the one that thinks it's in here somewhere. So when do I reject him? And I'm going to draw it on both sides, just in general, you know, but whatever, if it's one tail or two tail, when do I reject this guy? When I get far away from where he thinks it is. So if I get in there, I can reject the null. That's his area. Where's the H1? The H1 thinks it's out here somewhere. And again, depending on if it's a one or a two tail test, which side it's on and blah, 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 right? But the HO thinks it's in here and the HI thinks it's out there. So if my sample falls out here, it looks like this guy's right. It looks like this guy's wrong. Let that make unbelievable amounts of sense. Okay, maybe. If it's one tail, doesn't matter which, of course it does. I mean, so, you know, if it's one tail, I want you guys to realize something. So in this problem, it was less than 60. So in this problem, it would be a one tail down here. Is anybody not cool with that? Is that all right? The H1 says mu less than 60. So it would be a one tail down here. Is everybody okay with that? All right. I don't see any opposition. If I took a sample and I got something here, does that show evidence for this guy? In fact, I really want you to understand. I think the book made a couple problems like this. I didn't assign them. Just look at me. Just look at me. If the claim is the mean is less than 60, and we take a sample and we get a mean of 80, is there any reason to do anything further? If the claim is the mean is actually less than 60, and we take a sample and get a mean of 80, is that ever going to be evidence in support of less than 60?
No.
Hell no, I wouldn't do shit. I'd stop right there. Right? I might try to take another sample if I really believe that it is less than 60. I go, wow, I must have taken a really weird sample. So I go and do another sample. Right? And then if I get higher than 60 again, I start to go, well, shit, maybe I'm wrong. You guys understand? I went a little further than the problem needs, but that's because I got some good questions. So yeah, all day long, if it's one tail, it's got to be in that tail. The other side doesn't mean shit in that case, right? You can only show support for somebody who thinks it's less if it's actually less. Okay, I like it. Is that all right? You guys all right? Let me know if it's not all right. It's okay. I can explain it further. Did I miss any questions? I got a lot of chat happening. Oh yeah, the 107 that people desperately, for some reason, don't think I would have talked about unless they yelled at me. Oh, okay. All right. Can you be more specific? Explain. Let me clear all my drawings. All right. I'm not sure. What part do you need further explanation about? Because I don't know. Let's see. Did everybody understand how to determine what language to use in the conclusion? It's all about what your claim is, right? So maybe let's do this. Let me go to the board. All right, let me see. Where am I at? No, not in number 85, because 85 is not about a percentage. Oh, 107. Okay, I'm not there yet. I'm still on 85. Okay, so let me come up to the board. Oh, I got to turn Jupiter off. That's a phrase you don't hear too often. Jeff, can you turn Jupiter off? Okay. Let me see. I can be in Starbucks. No, I can have a lot of clocks behind me. No, okay. All right, so come here. Holy crap. All right, let's see. All right, now let's do this. Let's do this. Let's focus on this. All right, here's situation one. All right, you're no good. Go ahead. Claim is mu greater than or equal to 15. So that'll be this one, right? Because it's got the equal sign. Is everybody with me so far? Can you guys see that all right? Yes. Good, good, good. Okay. Leave it alone, Jeff. All right. That's worse. Oh, shit. All right. Let's say that I'm not gonna do a whole test. Let's say that I get to the end and my sample falls here. Right? So right there, I can say I have failed. I have failed to reject the null. I have failed. And I have failed to support the high. I like it. What language will you use for your conclusion? Which one is the claim? HO or H1?
HO.
HO. Which means, screw this. I'm going to use this language because it talks about the null, which is what the claim is. That's it. There's no guessing. There's no throw all the words down and pray. There's none of that shit, right? Which one is your claim? Use that language. So I'm not going to use a language about H1 because that's not what my claim is. My claim in this problem was HO. So then we have not found sufficient evidence to reject the claim that the mean is at least 15. Maybe. So what if I had a problem where the claim was the mu is is not 15. So that would be H1, right? because it does not have an equal sign. And let's say this time that two-tailed test, right? Let's say this time I get up here. So that means we have reject, we can reject the null. We can support the high. Which language will I use? Which one was my claim?
The high.
The high was my claim. So which language will I use? That language. Screw that language. I'm going to talk about the claim. I'm going to answer about the claim. When do you care what the claim is? At the very beginning and at the very end. That's the only times you care what the claim is. You're welcome. Somebody private chatted to me that it made sense. It's one of my favorite phrases. All right. Is that all right? That's the point I'm trying to make. There's no guessing. There's no, it purely is. And is everybody cool? Do you guys understand? These are the only things that could possibly happen. These are the only things. Reject the null, support the high, or fail to do those. And then you look to see which one's the claim. That's the language I'm going to use.
So
Yeah, it's
sorry, can you just go over how you would word the second one again for the conclusion?
well, this. Yeah, we have found, because we have found sufficient evidence to support the claim that the mean is not 15. So how did I know to use this word? How did I know to use that language? Because that's what the claim was. I talk about the claim. That only makes sense. Hopefully it does. Somebody makes a claim. They want to know what happened with my claim. Did my claim come out okay? Right? All right, so let's look at number 107, or else I'm going to have people try to find my house so they can beat me up, apparently. If I don't talk about 107. Waller, come out here. Ah. All right, let's see. 107. Where'd you guys go? There you are. What's so weird about 107? Let's find out. Here it is. Ooh, disease, Center for Disease Control. That's something that more people are aware of now. Let's see. So what's the problem with this one? Yeah, we definitely have to use NP and NQ because it's a percentage problem. So what's the issue otherwise? You know, can you see what the claim is? I mean, where do things break down for you guys? A few people asked me for this one. Now everybody went quiet. Okay. Yeah, of course there's no standard deviation given, right? Does everybody understand that 107 is an NPQ problem, right? Meaning the Z-score formula I'm going to use is this one. We don't need a standard deviation given. We create our own, right? This is the standard deviation. We create it. We don't need them to tell us what it is. Okay, good, good. I understand that gets weird because it's mixed in with these other problems where you need the standard deviation. But remember, percentages are kind of nice. You don't need as much information. Okay, maybe. So it's really, really, really huge that you stop yourself and make sure you know at the beginning, am I talking about means or am I talking about percentages? Because that changes several things. That means I'm going to have to look at NP and NQ to make sure they're both at least 5, right? I don't care about N greater than 30. Yeah. Do you understand? When you do this work right here, you are creating the standard deviation. Does everybody understand what I mean by that? Isn't that the standard deviation? It's on the bottom of the z-score formula, so it's the standard deviation. So when we throw P, Q, and N in it, we are creating the standard deviation. If Z star, okay, I don't know the specifics. What was the, oh yeah, 0.05. So I like your, oh, somebody's chatting to me, how would step C go? The problem with what you're writing is this. All right, let's see. The claim is at least 18%. So the claim is at least 18%. So that would go in here. Is everybody cool with me? Or does everybody understand that? You guys are like, I understand what you're talking about, but you suck. All right, I'm sorry. Does everybody understand what I'm talking about? That's what's more important. I don't care if you think I suck. Right? So where's the rejection region going to be for step C? Which side? Left or right? Or is it two-tailed?
Left.
Left side. I love it. So when I look up my z-score that goes here, will it be positive or negative?
Negative?
Yeah, because it's down there. What's in the middle is 0. So of course, z-score for this is going to be negative. So that's the one mistake that the private chatter made. You guys don't see this, but if z star is less than, and it's going to be negative 1645 when you look it up. We reject the null. We support the high. Is that all right?
Just wait. When we look it up, isn't it positive, but we just assume it's negative because it has to
We
be
don't
on that
assume it's
side?
negative. We don't assume it's negative. We assert our humanity. We say, we are the humans, chart. I made you. So we didn't want to waste ink. So we just made a chart that shows only the positive stuff, right? But that means that we have to know when to put a negative sign on it. And we put a negative sign on it when it's down here. Is that all right? So it would have really been silly to make the negative t-score chart. It would have been totally unnecessary. I really want you guys to understand that. Because we're the humans. We know when it's down there, it's negative. We don't need that. We are the humans, my friends. All right. Sorry, you don't want that. There's a reason I'm a teacher, not a singer. Now I got to keep singing it. All right, stop.
The N on that would be 150, right? Not 1200.
The N, yeah, that good point. This is that weird one, isn't it? Yes, this is that weird problem. The 1200 is totally bogus. Of the 150 students, 82 have smoked. So this is N. I have no idea why they did that to you. Oh, I see. Because they didn't talk to all the 1200 students. So that's fine.
So
Yeah, 150 students were chosen at random. So that's not as bad as I thought. Yeah. So that 1200 is extraneous. They just told you how big the school was. Who cares? I need to know how many total people they talked to. So that's totally N. Good catch. They didn't need to put that in there. They're just being evil. Oh, wait a minute. Do you have the grade comparison sheet you were talking about that includes 0? Oh, not yet. I'm hoping. Oh my God. This weekend was catching up with a lot of stuff. And some of you guys are like, dude, I still haven't graded my homework. Be quiet. There's a lot of stuff. So I'm hoping before Thanksgiving, I will create 2 columns on the grades in Canvas. One of them will tell you what your average currently is with no homework, and the other one will tell you what your average currently is with all the homework. And then if you turn in half of the homework, you're halfway between those. You can figure out where you are. Does everybody understand? I don't really calculate homework stuff until the end because everybody has until the end to turn in corrections and all that kind of stuff. So, or even turn in late stuff. You could turn in section 1-1 homework on the day of the final. you will not get much credit, but you will get more than 0, right? Okay. Finals cumulative anyway, might as well. You guys with me? Anything else? Any other questions?
Just wait. Oh, sorry, you can go first.
Okay. So we have 18 as the percentage. Do we use 18 and then the 82 over 150 to get the P, like the P minus like that, or
Wait. What's the little hat on this dude mean?
sample?
Good. So the 82 150 makes P hat. This is P. That is P.
Okay.
So then you can figure out Q that you need here too, right?
Yeah, I got it now.
I like it. And you need the Q down there also. Yay. Okay. Good. Good. Ooch.
So for the homework list thing you just mentioned, it's just two if you just didn't do the homework at all, and then
Yes.
one where if you got like 100% on all of your homework,
Yes.
or like, okay, got it.
So the two extremes. So if you're like, yeah, I turned in about half, or if you turned everything in and I said to correct everything, that means you have half credit right now. So you would be halfway between the two extremes. Here's something else that I don't tell people until it's almost done with the semester. I don't let homework fail somebody. Meaning, if I calculate your average without the homework grade included and it's a 70, but then when I put the homework in, it's less than 70, you pass. But if you have a B plus and then I put the homework in and then you have a B minus, you got the freaking B minus, right? So I will let homework take your grade down. I just won't let it fail you. Because not doing the homework is already doing a lot of damage, right? So if you somehow manage to cobble together a 70, even if you're not doing much of the homework, you pass. Is everybody with me? Some people hear that and they say, oh, so you're saying I don't have to do the homework. I like that. No, that's bullshit. That's complete, utter bullshit, right? I just telling you that now so that you can make a more informed decision about what to focus on. Should you focus on all the homework you didn't do? Should you focus on corrections? Or should you focus on the more recent stuff so you're ready for the quiz coming, for example, on Wednesday? Somebody chat at me? Yes. You're welcome. Everybody, how's that? Anything else, guys? I love this, by the way. This is awesome. Yes.
I have one more question. So like the homework, everything that's like has the X or the check mark on it so far, those are considered graded as of right now though, right?
The ones that have what? Oh, the X, yeah, that means incomplete. So something's wrong. And the check means it's good. It doesn't mean you got everything perfectly right, but it's good enough. And otherwise, if it's got, I don't know what shows up if I haven't even graded it yet. Is it like a little line or something? I don't know. Does that make sense? No? Well, shit.
Yeah, I got it. Sorry.
Somebody else
Then
is
if it's
saying,
incomplete,
sorry?
sorry, it's incomplete, it's half credit, correct?
Yes.
If you, okay.
Unless I say redo. If I put redo at the top of something, that means no credit until you make corrections.
Got it, thank you.
What is happening? Oh, I'm sorry. Somebody just sent me something. Oh, shit. I'm never going to remember to go back to that. What was I going to look up? Oh, shit. Hold on. Give me 1 second. I want to see what this looks like. Oh, wait. I should do it as myself. So on my end, it just shows up with a weird little symbol that looks like a little piece of paper with an exclamation mark on it. I don't know what it looks like on your end. Let me see. All right, I'm gonna go in like I'm a test. Let me look at my grades here. Oh yeah, it just says missing. There you go. I like it. Right? When you look at your grades, then it just says missing, right? If it's something I've looked at, it should say something else. All right, let me see. Yeah. So, yeah. I don't know. What if I... All right, screw it. I don't know what it looks like if I haven't looked at it yet. That's the question. I don't know. All right, I'm gonna have to investigate that myself, I guess. Shit, dang it. I didn't mean to do that. All right, I think it shows a paper. Yes, thank you. That's what I see on my end. I think it does show like a little paper thing with a little exclamation mark, a little tiny thing, right? That means I haven't looked at it yet. Thank you. Okay. Anything else, guys?
I had a quick question about 10.2.
Let me see.
Just
Yeah.
last week you were gonna say if it was extra credit or not.
Oh, I thought for sure, well, I pretty much have decided, did I not say? Let me think. I thought I was going off the assumption that I was going to make it an assignment. But I can.
You mentioned it, but you didn't confirm it.
True. Let me try. I'm trying something out this semester. I don't really like it, but let me give it one more try. This thing is called being nice. It's really foreign to me. So let me say this. We'll go ahead and make 10.2 extra credit. I feel icky. I don't like being nice. So we'll make 10.2 extra credit. All right, is that right with everybody?
Yeah, thank you.
Sure. So I got to remember to put that in there so people know. Oh, sorry. I'll stop. Let me see. Yeah. Let's see. Let me put that in here right now. So then I'll change the due date to be the day of the final. Some people have already turned that bad boy in. I love it. There we go. I'll just take the due date away. Go. How do I kill it? How do I kill the due date? Die. There we go. And then we put up here extra credit. Extra credit. The way I work extra credit homework assignments is it just adds on to your homework grade. So it'll take the place of a missing section or something. Sure, it's an early Christmas gift from me to you. No, being nice doesn't look good on me. This is what it looks like being on. All right, sorry. Thankfully, it took me this semester because next semester it's done. I ain't gonna be nice no more. Screw it. I'm done with it. That might be a lie. I don't know. Oh, will you be making a practice? I'm gonna make a practice final if that's what you're asking for. I was so if you're talking about like a practice quiz, I have done so many handouts and we have done so many sample problems. I don't see the purpose. Yeah, you know what's coming. You know what they're going to look like. You know what the problems are going to be. You know it. I really don't see much of a purpose behind making a practice test for this quiz coming up. Is that understood? You have a ton of handouts and you have all kinds of examples. Good.
The quiz is on chapter 9, right?
Chapter 9, exactly. All right. Hiroshi, what do you got?
I still have a question on 107.
Yes. Let me get back to it.
Thank you.
So what's up?
So why is the tail is on the left side on this problem? I thought the tail is on the right side because the claim is P is greater than and or equal to 0.18.
Yes. Did I draw it on the wrong side before? I thought for sure I did. So this will be P greater than or equal to 0.18,
Yeah.
meaning this is P less than 0.18. So then it's going to be here. Yeah, I'm pretty sure I drew it over there. That's a bad drawing. Woo-ha. It's here, right?
No, I thought it's the opposite.
Nope, because this always sets up the rejection region. H1 always sets up the rejection region, and that's less than. Why doesn't this ever set up the rejection region? Because it's got an equal sign in it.
Okay, I got it. Thank you so much.
I can't find evidence for equals, but I can find evidence for somehow different from. Good.
Thank you. I got it.
You're welcome. Okay. Anything else, guys? Did I miss anybody in the chat? I don't think so. I don't see anything. Okay. All right. All right, everybody. Okay, so moving on. We're about to get into something new, so I'm trying to go slowly in case there's any leftover questions. All right, I found something kind of funky. Let's see how this goes over. It's not the easiest thing in the world to find studies that do correlation stuff for some reason, but this is really, really funky. It's just something that was a study that was done recently that had the word correlation that I could find quickly. So what we're about to get into is conducting studies on if there is a relationship between two variables like this. Let me stop sharing for a second so you guys focus on me. So for example, is there a relationship between somebody's height and the probability that they play basketball? Notice I'm saying relationship, not does everybody tall play basketball? That's not at all what I said. Is there a relationship between height of people and them playing basketball? All right, I'll answer it for you. Yes, of course there is, right? Aren't most people playing, let me say professional basketball, aren't most people playing professional basketball on the taller side? Yes. When I was growing up, I loved basketball. Then I stopped growing up and I realized, oh shit. I have a really good fadeaway shot, but it only takes you so far. So if I'm sitting there watching people play basketball and I travel around and I watch people play basketball, I say there's a relationship between height and people playing basketball. So I believe that playing basketball makes somebody taller. What do you think about that? Of course, that's obviously silly, right? I don't go, man, I don't want to be tall. Let me go out and hit the basketball a few times. Oh, I'm an inch taller now. That's how I'm going to do it tomorrow. That's bullshit, right? So the funny thing is that's a very silly example of something that is really difficult in real life. Do you guys, do you understand, like it seems every year or so they come out and say something like eggs are good now, eggs are bad now, eggs are good now, for example, or there's multiple other things. It's good to drink wine. It's bad to drink wine. It's good to drink wine. It's bad to drink wine. Okay. And that's because there's a correlation between these things, but you have to do the right kind of study to see if one causes the other thing. Do you guys understand what's happening so far? So let me tell you a true statement. If teachers' salaries increase, sales of liquor go up. That is a true statement. Okay, I like the way you were acting. does that mean that teachers are all lushes?
No.
That's right. So what's another explanation for that? Why would that necessarily be true?
Better economy, people spend more in general.
If teachers' salaries go up, more than likely other people's salaries have gone up also, right? If teacher salaries go up, that's normally a sign of good parts of the economy. So other people's salaries have gone up. So in general, I'll bet you that the sales of all kinds of things have gone up a little bit. Do you understand? Do you understand? That's another silly example. But when you have things that aren't so obviously incorrect, it's hard to tease out, does this cause this? Or is there something else in the background causing it? So in that case, it wasn't the teachers causing that. It was the thing that caused the teacher salary to go up causing that. So it was like a third thing in the background. Are you guys semi with me so far? So all we can do, Santana, I'm sorry, I just called you out, but you're probably okay with it because you just had a very good point. The whole point I'm making is that causation and correlation aren't the same thing. So you're one step ahead of me. I love it. So I'm trying to build up to that. So the guy who thought that playing basketball causes the height to change made a mistake. All he could say was that there's a relationship between height and playing basketball. Now, obviously, we know from vast observations and experience that being tall has an effect on your playing basketball. We know that's true. But in general, we don't know. If we have like the age that you are potty trained versus how you treat animals later in life. If we say a correlation, but I know, thank you for that look. If we see a correlation between those two things, does that mean that one of them caused the other one? Not necessarily. Let me do this. Let me show you this. I didn't know if I should do this, but what the hell? You might get a kick out of this. There's a whole website called Spurious Correlations. Let me share this with you so you can see me type it in. It's called Spurious. There, I even have it all ready to go. Oh, you asshole. God damn. Oh, well, I'm sorry. I shouldn't be that mean. Well, damn. So normally, that sucks a lot. That sucks a lot. Let me see if somebody's got like screenshots of this thing. Barf. Man, that sucks. It's kind of funny. Here we go. Here's a couple of screenshots of stuff. Okay. Some of them are kind of, here we go. It's a good one. Stay with me now. Somebody's left. Ah, you asshole. Let me see. I need to look at the open image. Oh, there we go. Okay. Here's kind of, a lot of them have bad things. I'm sorry. But the U.S. spending on science, space, and technology correlates with suicides by hanging, strangulation, and suffocation. So there's a correlation between the red line is U.S. spending and the black line is suicides. So would you agree that they seem to be correlated? Does it make sense to say that they seem to be correlated? I'm not saying does it make sense that one causes the other. Remember, correlation has zero to do with causality. Are they correlated? Yes, they are. Why? Out of coincidence in this case, right? This is coincidence. There's no reason to think that if we spend more on science, that more people will hang themselves. There's no reason to believe that. Let me find one that's not so evil. Let's see. I was trying to get the one about Nick Cage. There's this one. Just because Nick Cage is just hilarious by himself. Open image. There we go, Jeff. Number of people who drowned by falling into a pool correlates with films Nicolas Cage appeared in. Now, this is not as good of a correlation. Would you guys agree? This doesn't really follow too well. All right, all right. But again, even if it did follow it, is that proof that if Nick Cage appears in more films, Nick, don't do it. You're going to make people drown. That's stupid, right? That is absolutely stupid. But there will be things that seem to be correlated that are just by chance. So my purpose for this, showing you that, is not to say that there's nothing that can be gained by doing a correlation analysis. Is to say that correlation analysis by itself doesn't tell me anything beyond the fact that they seem to be correlated. Why could they be? There could be a third variable. They could be, the causality might be the other way than I think, or they could just be correlated by pure coincidence. Are you guys semi with me? Like your answers are like, I'm halfway semi with you. So, okay. All right. So what I've done is I have put a handout up on the Canvas. Let me get to it. Here we go. So if you go to the Canvas, you go to modules, and you go to chapter 12, what the shit? So if you're following the homework sheet, where's chapter 12? Here we go. You know that we do chapter 12. The reason I do chapter 12 before I do chapter 11, right, filing bankruptcy, the reason I do that is because chapter 12 is relatively simple, and it does not involve hypothesis tests and all these distributions. Chapter 11 introduces our last chart. Chapter 11 is going to introduce a new chart. So I like to do 12 before 11 just to give us a little breather from charts and distributions. Yes? I don't know. And we'll see. You guys don't know. Okay. So here's this. So go ahead and go grab this. It's all about drinking beer and taking tests. All right, let me open this a different way so I can write on it. So if you can, go to Canvas right now, grab that sucker. Oh, where are you? Oh, crap. Where did I save you? Dad. Hold on, everybody. Hold on. Well, it's not there. That sucks a lot. All right, hold on. Where are you? You must be here. Do. Here, no, shit. Where are you? There. No, it's not it either. Damn it. Where? How you guys doing out there? You guys doing all right? Here it is. All right. Jeebus. All right, where'd you guys go? Okay, let me do this again. There we go. Oh, let me move this over here. Yep, it's just this easy. There it is. Okay. All right, so let's take a look. Oh yeah, I forgot about that, didn't I? Where did I put that? Oh, well, it's all right. It's fine. So read through this. So if an entire class went out drinking and they have a class and they have a test at 7 a.m. the next day, you with me? By the way, disclaimer, this is not a suggestion on an experiment to run, right? So Dean, if one of my students tries this and says it was me, this is the part of the clip where I could show you. No, I said no. Okay. Everybody with me? Everybody read that? So which one of these is probably more close to real life? The first one or the second one?
The first one.
Yeah, right? Real life probably wouldn't have it marching quite this perfectly, right? But both of these have a downward trend, right? I can draw a line. Holy shit, can you? Sorry. Actually, it's good that I did that. I can draw a line that sort of graphically averages where all the points are. That still isn't good, but it's better than the first one. Let me stop and say that again. Do you guys understand that I can draw a line that graphically averages all the points? That's the best I'm going to get, probably. Are you guys understanding what I'm saying? Doesn't that line I drew do a decent job? Pretend like it's a straight line. It does a decent job of graphically averaging out all the points. And this line does the same thing. It's just which one of these would you say is a stronger correlation? Which one would you say is stronger?
The second one?
Yes. I didn't even need to explain to you what it meant to be a strong correlation. You just kind of inherently understand this is a stronger relationship for damn sure. This one, a lot of the data points don't follow. Who is this person? What is true about that person right there? Each dot is a person. I've smushed them all up and put them on the graph. What's true about that person right there? What's true about that? They drink a lot?
No.
They didn't drink much compared to everybody else, right? But how'd they do on the test?
The worst.
The worst, right? This guy almost did as bad. So this person don't know shit. Doesn't matter how much beer they drink, right? They didn't study at all. They didn't come to class. They didn't do their homework, and they don't know shit. So it don't matter how much beer they're going to drink, right? What about this person? Do they drink a lot?
Yeah.
Yeah. I like that. It's very soft. Yeah. It looks like maybe the most. It looks like they edged this person out a little bit. Did they do pretty well on the test?
Yeah.
Yeah, not the highest grade, but definitely up there. Holy shit. Right? So this is the person that can hold their liquor pretty well and knows some shit, right? You guys with me? Why did I pick out those two? What's special about these two data points? What would you call them?
Outliers?
Beautiful.
Outliers.
They're outliers. Because everybody else seems to be following this trend, and these two are outliers. All right, let me stop for a minute. There was a lot packed into that. That looks more like a biology thing now. Like that is undergoing mitosis or something. All right. Sorry. Every time I say mitosis, I feel like I drop something on my feet. Mitosis. Thank you for that. These jokes are just for me. So if you get something out of it, that's good. Okay. So everybody with me? And let me ask you one more question. Would you say that this correlation is positive or negative? Both of these. Is it a positive correlation or a negative correlation?
Negative.
Yes, because the slope is negative. There's a downward trend. Kick ass. Yes. So obviously this next one, we'll start off where we ended up there. This one's going to be positive for both of these, right? Which one of these is stronger?
The first one.
Yes, this is stronger and so let's be a little more specific about what it means to be stronger. What does it mean to be a stronger correlation? Oops, somebody's chatting at me. I can't handle all this, guys. Okay, thank you.
Is it when more of the data points are around a straight, like would fit that line?
Yeah, in fact, it's not so specific. The data points are closer to the line. In fact, the line doesn't even have to go through any data points, and it can still be strong as long as they're close to it. So the further they are away from the line, in fact, let's give this the name. I just about said this guy's name. You're going to love this guy's name. This is the line of best fit. Isn't that what that line does? It best fits the data. And again, you can see some outliers over here. This person barely studied, but they did really well. And this person studied their ass off supposedly, and they did bad. So this guy is probably the one that doesn't understand what study means. Right? So I get that all the time. And this one is the one that might be retaking the class. So they really don't have to study, and they just know a lot of shit already. You guys with me? You guys have all sat next to somebody whose their book isn't cracked open, but they make A's on every test, right? Sometimes they just know the shit really well, so they don't need to study. That was me through a lot of my math classes until I hit some math classes, and they're like, holy shit, I got to study. Okay, and so this is positive. This one is stronger, but it's a positive relationship for both. Okay, we get the idea, hopefully, right? So let's get more specific. We're going to use, there's a way to measure the strength, and it's called the correlation coefficient or the Pearson product. I don't use these as much, not just because my stats teacher, my elementary stats teacher, his name was Mr. Pearson, right? He was an interesting fellow. So but I normally say correlation coefficient, right? So, and it gets the symbol R. So the correlation coefficient goes anywhere from -1 to 1. -1 would mean it's perfect negative. Well, what do you think perfect negative correlation means? It means that not only is it lined up going down, but it's perfectly lined up. All the dots are on the line. Are you guys with me? If every single dot is on the line of best fit, that is perfect correlation. If they go down, that's negative. And of course, perfect positive would be perfectly lined up with the positive slope. All right, let me stop for a minute. And of course, that means that a value of 0 means there's no correlation. So it could either look like measles, and so there's no line of best fit. It's not going anywhere. Or it could mean, oh shit, I know this is a lot, but it could mean something like, I have this situation. Aren't those perfectly lined up? But that is 0 correlation. I need to make a bigger picture somehow. Oh, dadgummit. I got no room for anything. Screw it. Let me erase some of this stuff. Here we go. So why in the world, if I had something like this, why would that mean, oh, shit and a half? Damn it, excuse my language. All right. Why would that mean this is 0 correlation? Because as one variable changes, does the other variable give a shit? Nope. It's like how high I can jump versus how tall the tree is outside. I jump higher, and the tree stays the same height. Look at the correlation. No, they're not correlated. One does not give a shit about the other one. Or if it's like this, same idea. If it's perfectly lined up straight up and down, that is no correlation. Because again, one variable does not give a shit about what the other variable is doing. It has to be some kind of diagonal line. Let me stop for a minute. That's a lot that I've thrown at you. How you guys doing out there? This is different, but it's not as like, it doesn't have as much going on as like a hypothesis test, right? The next thing, by the way, we're going to do all of this is the one section that I basically do all of the work in the calculator. All right. So I can get this value, this measures the strength of the correlation, and then I can also find the equation of the line of best fit. Right? So these lines I just drew up here, if I picked 2 points they went through, couldn't I figure out the line of best fit? If I did y minus, you guys remember y minus y1 equals m times x minus x1? Does that sound familiar to anybody?
Yes.
Yes. All right. So some of you guys might be thankful that we won't be doing that. So don't freak out if that's bringing back bad algebra memories. All right. So let's do this. Let's try this out. So this is actually on that calculator guide that's up there in Canvas. So I decided just to bring it here also. It's all the instructions you need for chapter 12. So can everybody take a minute, get your calculators out, and put this data into L1 and L2. Everybody with me? We finally have 2 variable data. And again, this is up on Canvas. So if you can get into Canvas and access it, that would be great. I'm going to pull up my calculator and get it ready so I can show you this stuff. Calculator. Calculate. All right, come on. Oh, wake up. There it is. All right, let's see. Oh, shit. It's going to be exciting. Everybody understand what's happening right now? Y'all should be doing something right. I'm going to put it in this calculator. Oh, shit. Okay. Oh, shit. What really, 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 really sucks is when you're putting data in and one column is not as long as the other column. That means you missed somebody. So I like to stop about halfway and make sure what I'm typing goes with, like right now I'm on the 90 and it goes with 2.3. So I make sure I'm not missing anybody. I have no idea if that made sense to you guys. All right, what happened to you? Oh, shit. So many technological problems. All right. Okay, I think I got everything in here. Yes, okay. Everybody got that in their calculator? Does anyone not have that in the calculator yet? Okay. Let me see, where did the calculator go? There it is. So let's look at this. So here it is in my calculator, L1 and L2. Right, so this is the number of beers people had. This person's interesting to me. They had 7/10 of a beer. Oh, and then this is the grades they made. So, all right, first thing is, get ready. We're going to create a scatter plot, which really just means plot these X and Y points. We're going to have the calculator do it for us. Does everybody see their Y equals button? And do you see right above that it says stat plot? That sounds intriguing. It sounds useful. So if you hit second Y equals, is everybody with me? Everybody do this for me right now. Hit 4, enter. Just in case you have some plots turned on from some who knows what. Let's just start with everything turned off. Right, so you should see plots off and then you hit enter, done. Then hit second Y equals to get back in. So everybody, all these should be turned off. All these 3, all 3 of these. All right, now hit enter to get into stat plot, into plot 1. Hit enter for plot 1. Turn them on. And then get angry at me because look at all the shit you could have done. There's histograms, there's box and whisker plots. Oh, that's too bad. But what we want to create is a scatter plot. We want this first plot. So make sure this is highlighted, right? Just hit enter and highlight this first guy. Is everybody with me? Let me know the minute you're not with me. And then make sure this says L1 because that's, oh, sorry. Go ahead.
Can you start over from the beginning?
Okay. So you got the data in there, right?
Yes.
Okay. Then hit second y equals. You see this stuff?
So y equals? No.
Second y equals.
Right, I don't see the y equals.
The y equals right up there in the upper left-hand corner of the calculator.
Okay,
Yeah.
I got it.
So hit second y equals, and you should see stat plots.
Yes.
Okay. Are 2 and 3 off?
They're all off.
Okay, so hit enter for number 1. And hit enter to turn it on.
Got it.
All right, now go to type, make sure it's the scatter plot, the little points. Make sure it's got L1 as X, because that's my XY table, right, that we made. L1 is my X's, L2 is my Y's. And then you get to pick, obviously I'm a square, I'm a math teacher, but you could be positive, you could be a big speck of dust, or you could be a small speck of dust in the universe. Those are just the symbols it's going to use to put on all the data points, right? Now watch this. Get ready to be completely underwhelmed. If you hit graph right now, first off, I've got some nifty shit from another class still in there. Oh, isn't that neat? Let me turn that off. Clear. If you hit graph though, most of you guys should just have an empty graph, right? Okay, now watch this. Anytime you put new data into your lists, you hit zoom. Can you guys see which one looks like it's going to help me out the most?
Zoom stat.
Yeah, number 9 for me. It should be number 9 for most of you guys. So if you hit zoom 9, that should be what you end up with. So I try to make it so that it pretty much looks like that first graph on the handout. All right. Is anybody having issues? Are you guys doing okay?
Mine doesn't stay on that plot graph.
What do you mean it doesn't stay on it? Does
So
it say
goes
an
to that, and then it goes to the error, syntax, quit, or go to.
Oh, do go to.
Okay.
I'll bet you anything it's going to take you to your y equals list. Make sure your y equals list is empty. Mine is not only empty, it's also very strange. So let me make sure mine looks the same as yours. So go to y equals, make sure it's all empty. Was there something in your y equals?
Yeah.
There's probably some weird shit in your y equals.
Yeah.
The other person that had trouble, did that help you? Other person?
Let me try.
Hit zoom 9 now and see what it does.
Yeah, that's good.
All right. Everybody else, somebody else said they had trouble, but I'm going to assume everybody's okay because I don't see any follow-up messages. Oh, Alexi, so what kind of error? Does it say syntax? Does it say go to? Go to then. Click go to, because then it's going to put the cursor on top of the problem. I'll bet you anything that it's in the y equals. Did you click go to? Go to, don't click Goku, because then you might get like a Kamehameha wave to your face. Okay. That joke was for a couple people. All right. Everybody else okay, I guess. Okay. So now, all right, that's not exciting, really. I mean, we can all plot X and Y points. Good job, calculator. Boop-de-doo. That doesn't make you worth $100. So stay with me. Where do we go? Where do we always go this semester in the calculator if I want to calculate something on data I've put in? Where do I go to calculate something from data that I've put in? Stat. And then what? Calc. So go to calc real quick. Which one of those? We're not going to do 2 var stats. I will show you the formula in the book for what we're about to do, and you'll see why I don't make you do the formula. Which one of those looks like it's going to help us with calculating a line of best fit?
Is it number 4?
Number 4. Notice number 8 and number 4 are almost the same thing. It's confusing. I have written to TI and I've asked them why this exists, and they wrote back to me and said, we cannot give out anything about the algorithms that are programmed, blah, blah. I'm like, screw you people. I have no idea why they have 4 and 8 both existing. That is so dumb. By the way, number 9, be careful. That's not line. Anybody know what ln is?
Natural log.
Natural log. If you have no idea what it is, just stay away from that. So we're going to use number 4. So what it's going to do, let's see what you guys get. So hit 4, make sure it says L1 and L2 because that's where your stuff is, and go down and say calculate. All right, let's see what we get. Let's see if you guys all get everything I got. Look at all the stuff I got. I got some cool shit. Is anybody out there not as cool as me?
Mine doesn't have the R squared or R.
Anybody else in that same boat?
Mine doesn't either.
Yeah.
Mine doesn't either.
Here we go, guys. Stay with me. Here we go. Here we go. You only have to do this once if the calculator you're using is yours, right? So stay with me. This is also on that on the sheet in the instructions. Hit second 0. This is a catalog of everything the calculator can do. It's kind of insane. Do you guys see the button that's got a D on top? So it's the X to the -1. It's the reciprocal button. Hit that button. I'm going to go to the D section of the catalog. Let me stop for a minute. So I hit this button right there after I went second 0, and then I hit this button right there so I get to the D part. Okay, I don't see anybody yelling at me. So now scroll down until you get to where it says diagnostic on. Again, you only have to do this once. I don't know why they did this. This used to be on the TI-82, right? That's like the old ass calculator that was around in the 70s or something. And you could turn this off to save computation power. We don't need that shit anymore. So if you hit enter, and then you have to hit enter again. Does anyone need me to go through that again? Okay, so now if you go stat, calc, number 4, we're going to go back to this again. And now everybody should have all of this showing up. Now tell me this. When does R tell me my correlation is strong? If R is close to what or what?
1 or -1?
Yeah, because that's where it's perfect. So anything close to those is strong. I already knew to expect this was going to be weak because look how spread out this shit is, right? So look, how could I see from what I see here? How can I see that this is saying it's weak? Get that weak shit out of here. What tells me that's weak here in this list?
It's close to 0?
Yeah, it's only negative 0.339. It's really close to 0. So I'll tell you this. Let me see, how can I phrase this so you guys won't freak out? I'm going to give you a number on the test. It's related to how large, let me just tell you this. It's related to the degrees of freedom of your sample. It's the R that you need to get past to show evidence of correlation. I think those words might freak people out. We're not going to do hypothesis tests. I'm going to say R must be greater than 0.7. So if you don't get bigger than 0.7 or negative 0.7 in this case, there's no correlation. Are you guys with me? And of course, it makes sense. It depends on the sample size. The bigger the sample size, the smaller R could be to still show evidence of correlation. This one, I can tell you right now, this is not correlation. The R for such a small sample would probably be around 0.6 or something. This R just won't cut it. All right, maybe. But let's do this. What is the equation of the line of best fit? Can you guys see it? What's the slope?
A.
Yay, so negative 2.54, right? Rounding it a little bit. And then the y-intercept is 89.8. So let's go ahead and put that. If I go to y equals, I can put that in. Negative 2.54x. Right there is your x. Right there is your x. Right there is your x. Do you see that? Right there? That's your x. And now I've forgotten the rest of it. Was it 89.8? I think so. Is everybody with me? So y equals, and you can put the line of best fit in. And then when you hit graph, there it goes. That's the graphical average of all the data points. Let me ask you this question without any preparation of what the hell it means. Would you trust that line of best fit to make predictions for this data?
No.
Why not? You're right. Why not?
It's not strong enough.
Not strong enough. I love it. If the R is not bigger than the required amount, I cannot trust the line of best fit. My best guess for anything is the average in that case. So here, you guys, I want you guys to do the other problem yourself. Actually, wait a minute. Did we finish answering all these questions? I'm going to stop sharing this. Let's go back to this sheet. Where are you, sheet? There you are. Bam. Here we go. So we got negative 0.339, I think, right? Is this a strong correlation? No. What kind of correlation is it? No evidence of correlation. Bam. If it was evidence, it would be weak. It would be very weak negative, right? Very weak negative correlation if there was correlation. And the line of best fit equation, I'm sorry?
When do you know if it's a weak or no correlation? Like, is there a numerical value?
Normally, so again, I'm going to tell you, in fact, let me try to find this real quick. I'm going to tell you what R has to be above. It's very much related to a hypothesis test where Z star has to be greater than 1.645 or something, right? So I'm going to tell you in a problem, I'll tell you what R has to be bigger than to show evidence of correlation. So in this case, if R had to be greater than negative 0.38, I'm sorry, negative 0.318, there we go. And not greater than, but I think you guys understand what I mean. Like further away from 0 than this. Is it further away from 0 than that? Yes. but is it close to -1? No. So then my answer here would have been very weak negative correlation, because there is evidence of correlation then if this is what was required. It's just not strong correlation. It would be very weak correlation. Right? But like I said, in this problem, the R for such a small sample, it probably is 0.6. I can look it up here in a minute. I'll do that while you guys are working on this other problem. In which case, this would be no evidence correlation. It's not even weak. It's just not there. All right, let me see. How do we find the line best fit? So again, shoot, let me see. Where are you? There you are. So again, you go to Stat, Calc, number 4. L1, L2. There's your A, that's your slope, -2.54x, plus B is your y-intercept, 89.83. So this is sort of like statisticians saying, we're not math people, we're statisticians. We're not going to use an M, we're going to use an A. So, just deal with it. All right. So what I want you guys to do is to try to do everything we just did for this problem. Yes? Okay. So I'll sit here and put it in my own calculator also. Let's see. Where did you go, calculator? There you are. Let me know if you have issues. Issues related to statistics, not just, in your life. Okay. Oh, somebody's chatting at me. I can't see it. Hold on. There we go. Oh, you mean how do you get the line to show up in the calculator? Is that what you're asking? Yes. So you just hit the y equals button and put it in the equation. Oh, yeah. I'm sorry. So if you have one of the older calculators, it's actually easier because it defaults to list 1 and list 2, Frida. So you could even just hit linreg and then enter immediately, and it'll give you all the same information we just got. Does that work? Yeah. So the older one is actually kind of better. It's a little less stuff to go through. All right, let me see. Let me catch up with you guys here. Oh, shit. What's happening? Oops. Dadgummit. Let's see. Well, that sucks. Oh, okay, I'm fine. I don't know what the problem is. Oh, that's the problem. Okay. That is a problem. Oh, there's 2 12s. Shit. All right. Okay, hopefully that's right. Okay, all right. How you guys doing out there? So here's what I'm getting. Am I wrong? I could be wrong. That doesn't look familiar.
That's what I got.
Oh, good. I feel a little bit better. So here's what it looks like in the older model, right? In which case you don't even need to tell it L1 and L2. It defaults to L1 and L2. Is everybody doing okay out there? So with these kind of problems, you just have to scan your calculator, the graph that you make, and send it to me. For the final exam, you're going to have to do that with this kind of problem. You got to scan it and submit it with your final. The graph you get at the end. What do you guys think about this correlation? Is it better?
Yes.
Hell yeah. I forgot I was going to look up. Oh, man. All right. I got to find that. I got a little chart. Oh, Riley, did yours show the R value from earlier? Did you follow? So you didn't follow along when they did the whole second zero, hit this button, go down to diagnostic on, enter, enter. Okay. So do that. And then it should show up. All right. So this one definitely, it's a larger sample and R is decent, right? It's not like really close to 1, but it's a lot closer to 1 than the other guy. So on a quiz or a test or a final exam, I would make the R obviously strong, like 0.9 something, or obviously weak. I'm not going to make you like this one. It's sort of like tasting a wine. You would say, oh, this one's got hints of strength, but it's also not that strong. So what the shit? But this is a decent correlation. I would say it's decently strong positive correlation. All right, but I don't want to put you in a situation of which adjective do I use for this, Jeff? I don't want you to be in that situation. How do I get the graph to show up? To be honest, everything is set in the calculator. All I have to do is do one thing. If I hit graph, it's going to suck. Look, I see 1 dot. So first thing is, let me go to y equals and take that out. That's from the other thing. And then what do I have to hit every time I put new data in?
Zoom stat.
Stat. I love it. And there it is. And that should look like one of the two on the grade versus hour studied or some whatever that was on the sheet, right? All right. Now let's see. I'm going to show you this. This is something people might not enjoy, but oh well. You can see the equation of the line, right? So you could do just like we did last time, 0.66x plus 70 or you can just make it 71. Screw it. But watch what I could do. Watch what I could do. I don't know if anybody noticed. You can't do this in the older calculator. Sorry, Frida. But in the newer calculator, you don't have to do this if you don't want to at all, because you could just go to y equals and put the damn thing in there. But watch, just in case. See where it says store regression equation? You don't have to do this if you don't want to. Do you see the variables right there? Vars. If you go to vars, go to y variables, function, y1, it'll store the equation in here for you in all of its glory. Look at that shit. Do you have to do what I just did? No, you can put it in there just like we did the first problem, right? Just if you want to, you can tell it to store the equation. Sure. So if I go calc number 4, and where it says store regex, so that means regression equation. I go to variables, I go to y variables, I go to function, y1. You can use any y you want to, really, but so when you hit calculate, it'll store the equation in here for you. You won't have to put it in there manually. And then when you do zoom 9, bop, there it is. Look at that. That's so beautiful. Oh, that's pretty good. We can stop right there. We're going to do more of this on Wednesday. But I think, I mean, that's pretty good. What do you guys think? Any questions on what we just did? So we have a bit more to discuss. We'll do some more examples on Wednesday.
Which button did you push to bring up that graph again?
Oh, to be honest, I had already hit zoom 9. So then you could just hit graph and it'll bring this up. Is that all right? Does that work?
Yes.
Okay.
How did you get the line again? Mine's not showing.
Let me clear this out. So you could just do like we did before. Oh, shit. Jeff, there we go. Blah, blah, blah. You could just take this 0.6, you with me, 0.66x plus 71 roughly. So I could just put in here 0.66x plus 71. You just put it in there manually if you want to. And then if I hit graph, bam, there it is. How many data points does that look like it goes through? So, to be honest, it doesn't even go through that one. So it doesn't go through any. But didn't we say that it was a strong correlation?
Yes.
It doesn't go through any data points. Why does it look like it goes through that one? Because it's a big ass box. Let me make that. Now I forgot how to do it. It's been so long. Okay, here we go. Let me make that a little speck. I'm a little speck in the universe. It's been so long since I've not been a square. It's kind of weird. Oh, you can't even see that. That's let me do this again. Hold on. Let me do this. Yeah, see, it missed that one right there. Yeah. All right. You can't see that too good, but oh well, too bad. So my point is, it could be really, really strong correlation, but not go through a single data point, because strong correlation just means that not many of the points get very far away. And to be really, really, really technical, the average squared distance from the line to each data point, when that's small, that means it's strong correlation. So in a very strange way, the line of best fit is like the average, and the R value is related to a standard deviation. Isn't the standard deviation how far data points get away from the middle, from the average? Isn't R kind of give me an idea of how far away the data points get away from the line of best fit, which is the average? Very, very similar ideas. Really, really, really cool. And, just in case you're curious, we're not going to talk about these in this class, but there is quadratic regression, meaning parabolic regression. There's cubic regression. There's quartic regression. There's natural log regression that we already talked about earlier. So if I do quadratic regression, watch it. We're not going to do this semester, but just to show you, it gives me an equation of a parabola. And notice it doesn't give me R, it gives me R squared. So I'd have to square root this damn thing to see what the hell, right? Anyway, I think that might be enough. So you guys, officially class is over. Let me know if you need to hang out, if you have any questions.
Have a nice day.
You too. Thank you.
Thank you.
Anytime.
Thank you.
You're welcome. All right, guys. I'll see you later.